So, Bismillah Rahman Rahim. Today we will discuss one of the important chapter and a topic in our database management course, and that is related to the relational algebra and the relational calculus. And by if let's suppose if we see the outline, what we discussed in this chapter. Number one, we will discuss the unary relational operations. Then we will discuss some relational algebraic operations from set theory. Then we'll discuss the binary relation operations. Then we talk about some other related operations which is not listed in the set or a binary one. And then we will execute queries, and we will see that how those queries will be performed by using relational algebra. And then we talk about the calculus, relational calculus, and which includes the tuple relational calculus, domain relational calculus, and for that purpose we use the company database which is given in this chapter, and throughout all these chapters in this book has considered this example to for execution. So we start with the relational algebra overview. So, what is algebra? Whenever we talk about algebra, uh, the very concept which comes in our mind is that we are talking about some sort of operators, or we are talking about some sort of operations in a particular context. So relational algebra again is what is the basic set of operations, of course, for the relational model. And we talked about the relational model because since from class one we are talking about the relational model. So that algebra is actually applied on that relational model. That is why we termed as a relational algebra. Okay, these operations enable a user to specify basic retrieval request. So actually these operations help user to dig out or to find out the whatever the required from the database. And obviously those operations actually define how you can get to that information which is there in the database. For example, if you have the employee table, how you want to have to extract few tuples out of the employee table based on certain conditions. Might be you are interested on those employees who works for more than 10 years. So it means that you are interested in specific tuples or records. So how you get it? Obviously, you have to have some operations. You have to apply some operations. So we will obviously discuss how those operations are defined. The results of an operation is a new relation. So remember one thing, these operations, whatever we discussed in the relational algebra, make your mind that these operations are applied on what? On relations. So let's suppose we talk about a company database. In a company database, we have an employee relation, department relation, project relation, dependent relation. So if we apply algebra on that, it means algebra is applied on the relations. And when you apply that operation or an operator to the relations, so the resultant is also a relation. That is the third point. The result of an operation is always a new relation. Let's assume that you are interested in those employees who worked, let's assume, more than 10 years in the company. So the resultant is always a relation which includes those tuples which qualifies that criteria. This property makes the algebra closed. That is why we call it closed. That is the property which I have discussed. So all objects in the relation algebra are relation because the operations are applied on those relations. So that these are also called objects. The algebraic operations thus produce new relations as we have discussed. So these can be further manipulated using operation of the same algebra. So let's assume that we have applied an operation and we have retrieved another relation. So you might apply another operation on the retrieved relation. So that can also be used as an input for any other relational operator as well. So it is a process. So sequence of relational algebraic operations forms forms a relational algebraic expression. So if you have more than one operations involved in a sequence, let's assume you have taken few tuples from a relation, then you have combined those tuple with to another relation, and then you have taken a specific tuples from the result. So what you did, you apply actually three operators consequently. So the sequence of relational algebraic operations and such an expression is called relational algebraic expression. The results of an relational algebraic expression is also a relation. So whatever the complex expression is, the resultant is always a relation that represent the results of the database, or normally we call it a query, or in other words you can say it is a retrieval request. So brief history of algebra, or the origin of algebra. So algebra itself is it is actually first introduced by Muhammad ibn Musa al-Khwarizmi, and that is about 800 to 847 CE, from Morocco, wrote a book titled Al-Jabr, about arithmetic of variables. Because remember, when we talk about algebra, it is a generic thing. So wherever we need operators, that is called an algebra. But here, which algebra is relevant? We're talking about relational algebra. But actually, the concept of operators was first defined by Khwarizmi, and that book was very famous, and that is being translated in many languages, starting from Latin and then in all the languages. And the meaning of algebra gave the algebra its name. So Al-Khwarizmi called variables shay. Shay is Arabic for things. Spanish translated Che as Ze, X was SH in Spain. So with different language has different pronunciations and different expressions. So obviously, whenever we have those translations, so sometimes the phonetics are different. So if the phonetics are different, then they actually have a different look. In time, this word was abbreviated at X. Where does the word algorithm come from? Algorithm originates from Al-Khwarizmi, which is the reference, and just we start the overview. Now, relational algebra consists of several groups of operations. First is called unary. Why we call it unary? Because these three operators can apply on a single relation. So when operators are applied on a single relation, then they are termed as unary relation. For example, the first operator is called select, which we will discuss in the next slide. If you want to apply select, select can only be applied if you want to apply it on employee. Yes, you can do it because employee is only a single relation. So you can apply select on employee. You can apply project on employee. Yes, it is possible. Why? Because these are unary. So it applied on a single relation and gives the value. And always remember that select actually is represented in terms of sigma. So we normally use these values or these symbols when we represent things. So we normally do not use the select. So always remember that sigma is actually in algebra, we call it select. Okay. The second operator is called project. Okay, the working of select and project and all other operators will be discussed in the next slides. So I will not discuss over here. Here I just give you the different meanings of these categories and the representation. Project is represented with a pi symbol. Project is represented as a pi symbol. So select, you can say what? Select is a relational operator. Yes, select is a relational operator, and it is represented by sigma. Project is also a unary relational operator. It is all represented with pi, and rename is also a unary relation operator, which is represented as row. Normally we call it row. Then the second category, if you see the second category, these are called set theoretic operations, or those operations which are taken from set theory. So if you remember your first or second lecture, when I defined the concept of relational model, so there we have discussed that relation itself, Cord defined relation as a mathematical structure, and the relation is, according to the Cord, relation is like a set, and he proved that all those operations which are applied in a set theory can also be applied on a relation. So all those operators are very famous to you because these operations are taken from set theory, and those are called union, which is similarly represented as the same way. Intersection, you can see the same representation. Difference, or sometimes we also call it minus, and another important set theoretic operator which is called cross product, or in other words we call it Cartesian product. And we will describe these operators with examples in the next coming slides. Then the third category of the relational operators are called join. Okay, and join also have other variations as well, which you can see in the fourth category, that outer join, inner join, so on and so forth. So we will discuss these as well. There is another operator here which is defined under the binary relation operations, is called division, and here you can see the other forms of joins and aggregate functions as well. So in many queries we are interested to know what is the total value, we are interested to know what is the average value, who got the maximum mark, who got the minimum mark, who got the average marks, how many students have participated in the exam. Okay, the sum of all the marks obtained in assignments, presentations, and the final exams. So these are all called the categories of the relational algebraic operators. So again, the recall of the company database and why it is important whenever we are doing or we are writing these expressions. It is also important to have some example at your end where you can apply those operators so that you can see yourself that how you can have the resultant tuples. So therefore, again, for that purpose, the company database is used, and the same schema of the company with all referential integrity constraints are represented here. These arrows shows the relationships of various relations in terms of the reference key, and that defines the whole schema of the company. And here how many relations are involved? Number one, the employee. The second is department. The third one is department locations. The projects works on independent. So we have discussed this in the entity relationship diagram lecture, or the enhanced entity relationship diagram lecture as well. So now we start with the unary relational operations, and the first one which we will discuss is called select. The select operation denoted by, do not misguide yourself. That select is different from the select which is there in the SQL, although they have resemblance. But here we are not talking about SQL operators. Here we are talking about algebraic operators. Actually, SQL is a product, and that product is actually based on the algebraic operations or the calculus. So here we are talking about the first operator, that is called select operator, or an operation which is denoted by sigma, is used to select a subset of the tuple from a relation based on the selection condition. That is very important. When select is used, number one, select is a unary operator. So obviously it can be used with a single relation. What it does, it takes out the subset of the tuple. Let's suppose the in the employee relation we have 20 tuples or 20 records. So if you apply select, obviously you will refer a condition, and according to that condition you want to take some tuples out of the employee. Let's assume what you can do. For example, you might say all those employees who have been working more than 10 years in the company. So you only want to see those records. Let's assume you only want to see the records of the employee who lives in Karachi, or you want to see the employees, uh, or you want to refer those employees in terms of, let's suppose, their designation which is there in the employee table. So what you did, you take out the selected tuples, you take out the subset of the tuple based on, there must be some criteria, that is called your selection condition. The selection condition actually acts as a filter which you applied on that particular relation. So normally in any database, whenever we are making queries, we are referring to some tuples or a subset of tuples, we have to define conditions. So we are not interested all the time in all the tuples of the relation. So keeps only those tuples that satisfy the qualifying condition, whatever the condition is. The tuples satisfying the condition are selected, whereas the other tuples are discarded. They are not for my use. So I only pick those tuples which are required. So let's take an example and consider the employee table. So select the employee tuple whose department number is 4. So for select, the symbol is what? The symbol is sigma, and whose department number is 4. It means condition is applied with sigma, as you know, as a subscript, where DNO is equal to 4, and you have applied this condition to a relation employee, and that comes in bracket. So department DNO is equal to 4, employee. What is the resultant? The resultant is you can only see those tuples where you can see the records of only those employees who belong to department number 4, and all other employees will not be seen. Let's assume another query. Select the employee tuple whose salary is greater than 30,000. So this actually is represented as sigma because it is a select query, and an attribute, what attribute is used? Salary attribute is used, which is there in the employee. So salary is greater than 30,000, which is actually your filter or a qualifying condition, you can say, or a selection condition, and this is applied to the employee. So this will give you the resultant tuples which qualifies this particular condition. In general, the select operation is denoted by sigma, and you can see that is the basic syntax of select, that we have the sigma selection condition R, where the symbol sigma is used to denote the select operator. The selection condition is what? Is a Boolean conditional expression specified on the attributes of relation R. That can be a Boolean condition, that might be a conditional expression, as you have seen in the previous examples. Tuples that make the condition true are selected. So those tuples who met that conditions, only you can see those tuples. On all rest tuple you cannot see. So that those tuple will be represented, or you can see will be appear as a result. So let's suppose if two tuples qualifies the criteria, then you can see the two tuples. So you see two tuples again in the form of the relation, because we have discussed earlier on that whenever you apply that of these operators, the resultant is always a relation. Okay, so tuples that make the condition false are filtered out. Similarly, those tuples which have not fulfilled the criteria are filtered out. So these are some properties which you have to understand whenever you apply select operation. The select operation sigma, select condition R, which we have discussed in the previous slide, produces a relation S. The resultant is what? Is a S that has the same schema or attribute as R. So it is obvious that whenever we apply a selection phenomena or a selection operator on any given relation, the resultant relation must have the same attribute. It is not possible that the resultant attribute might have different attributes which are not there in the R. So that is the basic property. The second one, if you see the second bullet, that is about the commutative property. So let's assume that you have a sigma with condition 1 and there is a condition 2 as well. So there are two conditions involved. For example, those employees whose salary is greater than this, and also those employees who belong to department number 1. So we have two conditions. So either you can apply the condition 2 to R first, and then the resultant can also have applied that particular condition, the resultant if condition 1, and similar, it is equal to what? It is equal to this expression where the condition 1 is first applied to R, and then the resultant, whatever the resultant relation is, where you have applied the condition 2. That is called what? That is called the commutative property, because we know commutative property means, let's suppose we talk about we say x into y is equal to y into x, or we say 2 plus x is equal to x plus 2. So similarly here the conditions does not make any difference, so because it holds the commutative property. Because of commutative property, a cascade sequence of select operations may be applied in any order. So let's assume now we're talking about not two conditions, maybe you might have more than two conditions. The same principle will be applied. So any of the combination can be used. Either condition 1 is applied first, then 2, and then 3, or you applied 1, then 3, and then 2. It's up to you. That is why it is called as a sequence or a cascade. A cascade of select operations may be replaced by a single selection with a conjunction of all the conditions. So instead of applying all the conditions separately, you can also use and you can represent the same conditions with sigma. So here you can say the condition 1 and condition 2 and condition 3, and then the relation on which you want to apply it. The number of tuples in the result of a select is less than the number of tuples in the input relation R. So whenever you have a resultant is always is less or equal to the number of tuples in the input relation R. So let's suppose if you apply a certain relational operator on employee relation, so what will be the result? It can be either all those tuples which qualify, or there will be less than those tuples which qualify. It is not possible that you have more tuples which qualify. So these are the select, you can say, operator or operation properties which must hold. So here you can see the example, now the representation of a project. Project operation is denoted by pi. This operation keeps certain columns attributes from a relation and discards the other column. Remember, select is used to qualify a relation in terms of tuples. Here, the project operator, which is a pi, is used whenever you want to restrict the table. Let's suppose you are only interested in might be two or three attributes of the table rather than all the attributes. Let's assume that that employee relation, you are only interested in the first name and the last name, and you are not interested in the address and the salary and the other attributes. So if you want to do this, then you have to use the project relation. So in other words, you can say the project creates a vertical partitioning. The list of specified column is kept in each tuple. The other attributes in each tuple are discarded. Those attributes are not required. To list each employee's first and last name and salary, now here we are interested in only three attributes. So if you are only interested in few attributes of the relation, then you have to use project. And for project, the symbol is what? Is a pi. So you see pi is here. So in which attributes we are interested? The L name, last name, comma, F name, the first name, comma, the salary, and the bracket is the table. And here the table which we are referring is employee. So here you can see this expression. Now this is called an algebraic expression. This algebraic expression only deals with the project operator. So the general form of the project relay operation can be defined as pi, the attribute list as a subscript, and the relation R, and which gives the desired list of attributes of the relation R. The project operation removes any duplicate tuples. So this is because the result of the project operation must be a set of tuples. So again, whenever we apply this to a relation, the resultant is also a relation. So no duplicate tuple can also come or in the resultant table. Project operation properties. Similarly, we have discussed the properties in the case of selection operation or a select operator. Here we are talking about the project operator. The number of tuples in the result of projection, which is the pi, the list of attribute R, is always less or equal to the number of tuples in R. So that if, let's suppose, in the original relation employee we have 7 attributes, and if you want to apply project, so obviously you are interested in less than the number of those attributes. You might be interested in 6 attributes, 5, 4, 3, 2, or 1. So in the list of attributes include the key of R, then the number of tuples in the result of project is equal to the number of tuples in R. So if, let's suppose, you want to retrieve some values from a particular relation and you refer the key attributes, so you will obviously get all those tuples which are there defined in the actual relation. So but remember one thing, select holds the commutative property but project does not hold the commutative property. So project does not hold the commutative property. It means that if you let's suppose if you take in few attributes of R and again you are taking few attributes of R where we have list 1 and list 2 which are not equal, so therefore the commutative property does not hold in the case of project operator. And here you can see the result. Here you can see that your actual relation was A and you have applied, let's assume, the A represent the selection. Here you are interested in only those employees who have, let's suppose, the salary greater than 3,000, so 30,000. So you only have three tuples. In the B diagram, you can see here you have used the project operator, and you are only interested in three attributes of the employee relation, which are the last name, first name, and the salary. So these again you can see as an output. So all these outputs you can see are actually in the form of the relation that we have discussed in the initial slides. The resultant of those operators or operations are always relation. We may want to apply several relational algebraic operations one after the other. Now remember, when we talk about a relational algebraic expression, it means that we can apply those operators combined together. So when we apply those operators combined together, it forms an algebraic relational algebraic expression. So we can apply one operation at a time and create intermediate result relation. So it is up to us. Either we can do it at once or we can do in steps. So one for if we apply one operator, we get the result. We apply the other one, we get another result. And until we apply the last operator, we have the final result. So it's up to us how we can break those relations. So here you can see that to retrieve the first name, last name, and salary of all employees who work in department number 5, we must apply a select and a project operation. So that is the query we have. So in that query, if you see in detail, you can see that here the projection is also involved and selection is also involved. So you can break it as well. So we can write a single expression and we can also use the break expression. So in the second bullet, you can see the single expression. In the single expression, you apply the sigma with department number 5 with employee. That is the condition that employee has to met. And you are only interested in these three attributes as an output. So the project will come outwards. That is pi, f name, l name, and salary. And then it is applied to the employee. Or you can do it in two steps where first you take the tuples out of the employee where department number is 5, and whatever the result is that goes into this relation, which is an intermediate relation, and you apply pi to this intermediate relation to have the final results.